Good morning. My name is J. Rutvik. My ID number is 21951A05G2. I am from CSSC section. Today's subject is chemistry. My topic is absorption process. Absorption. The term absorption was first coined in 1881 by German physicist named Heinrich Kaiser. Absorption is often described as a surface phenomenon where particles are attached to the top layer of material. It normally involves the molecules, atoms, or even ions of a gas, liquid, or solid in a dissolved state that is attached to the surface. Absorption is mainly a consequence of surface energy. Generally, the surface particles which can be exposed partially tend to attract other particles to their side. Interestingly, absorption is present in many physical, natural, biological, and chemical systems and finds its use in many industrial applications. We will learn about the concept in detail below. What is absorption? Types of absorption, physiorption, and chemiabsorption. Absorption characteristics. Absorption isotherm. Differences between absorption and adsorption. Applications of adsorption. What is adsorption? Adsorption is a process that involves the accumulation of a substance in molecular space in a higher concentration of the surface. If we look at hydrogen, nitrogen, oxygen, these gases absorb on activated charcoal. Meanwhile, we have to note the is different from adsorption. The two processes involve totally different mechanisms. For the adsorption process, two components are required. Adsorbate substance that is deposited on the surface of another substance, for example, H2, N2, and O2 gases. Adsorbent surface of a substance on which adsorbate adsorbs, for example, charcoal, silica gel, alumina. Adsorption enthalpy. Absorption constants are basically equilibrium constants. What it means is that they also follow or obey the Van Hoff equation. As can be in the formula, the variation of K must be isothermic, the that is at constant coverage. If we start from the BET isotherm and assume that the entropy change is the same for liquefaction and adsorption, we obtain delta H equal to delta H liquid minus RT L and C. Types of adsorption. On the basis of interaction forces between adsorbate and adsorbent, adsorption is of two types: physical adsorption and chemical adsorption. Physical adsorption. This type of adsorption is known as physiosorption. It is due to weak Van der Waals forces between adsorbate and adsorbent. For example, hydrogen and nitrogen gases absorb on coconut charcoal. Chemical absorption. This type of absorption is also known as chemiabsorption. It is due to the strong chemical forces of bonding type between adsorbate and absorbent. We can take the example involving the formation of iron nitride on the surface when the iron is heated in N2 gas at 623 K. Absorption of gases on a solid is a spontaneous exothermic reaction The amount of heat liberated when a unit mass of a gas is absorbed on the surface is called heat of absorption. Physiabsorption and chemiabsorption. Absorption characteristics. Characteristics of physical absorption. This type of absorption is caused by physical forces. Physiabsorption is a weak phenomenon. This absorption is a multi-layered process. Physical absorption is not specific and takes place all over the adsorbent. Surface area, temperature, pressure, nature of adsorbate affects physiabsorption. Energy for activation is low, that is 20 to 40 kilograms per mole. Characteristics of chemical absorption. This type of absorption is caused by chemical forces. It is very strong process. This type of absorption is almost a single layered phenomenon. Chemical absorption is highly specific and takes place at reaction centers on the adsorbent. Surface area, temperature, nature of absorbent affects chemical absorption. Energy of activation is very high, 40 to 400 kilojoules per mole. Absorption isotherm. Absorption is usually described by isotherms. It is due to the fact that temperature plays an important role or that it has a great effect on the whole process. Moreover, there are several isotherm models that are used to describe the absorption technique. This includes Freundlich theory. Freundlich absorption isotherm is obeyed by the absorption where the adsorbate forms a monomolecular layer on the surface of the absorbent. The formula is x by m equal to kp to the power of 1 by n. X presents the amount of gas absorbed on the molecular gram of absorbent. K and n are absorption constants. P is pressure, n always greater than 1. A major drawback of Freundlich adsorption isotherm, it fails at high pressure. It could not explain the multi-layer adsorption process. Langmuir theory. In 1916, Langmuir proposed the theory of adsorption of a gas on the surface of the solid to be made up of elementary sites, each of which will absorb one gas. It is assumed that all absorption sites are equivalent and the ability of gas molecule to get bound to any one site is independent on whether or not the neighboring sites are occupied. Additionally, it is also assumed that dynamic equilibrium exists between absorbed and non-absorbed gas molecules. Application of adsorption. Air pollution masks. These consist of silica gel or activated charcoal powder. When dust or smoke are passed through them, those particles get absorbed on the surface of of these materials. Separation of noble gases and diverse flask process. A mixture of noble gases of NeAr, Kr is passed through Deus flask in presence of heated coconut charcoal. Argon and krypton gets absorbed, leaving neon. Purification of water. By the addition of alum stone to the water, impurities gets absorbed on the alum and water gets purified. Removal of moisture and humidity. Moisture in the air is removed by placing silica gel on which water molecule gets absorbed. Absorption chromatography. It is used to separate pigments and hormones. Ion exchange method. In this of in this method of removing the hardness of water, calcium and magnesium ions get absorbed on the surface of ion exchange resin. In metallurgy, in the froth flotation process of concentration of ore, The particle gets absorbed on the fruit. Difference between adsorption and absorption. Absorption. Complete deposition of the substance in another substance is absorption. It is not a surface phenomenon. It is not spontaneous. It takes place uniformly throughout greater molecular interaction. It involves the application of potential in the absorption of water by root hairs. It is not subdivided by adsorption, deposition of substances on the surface is known as adsorption. It is the surface process. Adsorption of gas on solid is spontaneous. It does not take place uniformly. Less molecular interaction. There is no involvement of potentials during adsorption. Surface absorption is absorption. It is subdivided. Thank you.